Happy Wednesday, and thank you for joining today's webinar led by Andrea Kropp, our machine learning engineer who brings a wealth of information to this role, having led data science teams at Fortune 500 companies. She's been on the inside and now she's on the application side. With that, Andrea, take it away.
Great. Thanks, Adrian. Yeah, excited to be here today. Have a lot to show you. We're going to do a lot of different things on screen, some low code, some showing some code. Don't be afraid of the code. I'm going to explain what all of it is doing. But really today we want to focus on complete pipelines. So we don't want just a computer vision model that sits on a shelf for research purposes. We want to create complete pipelines for real world use cases. And I'm really excited about the many, many CCTV cameras that already exist in our world, in our environment, and what organizations can do with the video feeds that they already have. So that's really my goal for today, is to inspire any of you who are already capturing video from a CCTV to think about like what else you might be able to do with that, combining the power of computer vision and Snowflake. So I am going to show some slides. You can see I have a lot of different tabs open. We're going to do a lot of things live here. And just now, for those of you who were here early, we were watching this YouTube live stream. This is called the Four Corners live stream. It's from Coldwater, Michigan. It's going to be the basis of our demonstration today. But we really could have picked any live stream on YouTube. And as you're seeing, we're doing a little bit of live inferencing. So we're sending images from this live stream through our platform Landing Edge. And we're detecting things like passenger cars and trucks, any school buses, any ambulances, any pedestrians. So I'm going to stop this at the moment. We may come back to it later. And we've got a variety of different demonstrations that you'll see. So I will preview for you. We've got a couple other demo projects, one connected to this live stream. This is great for wildlife monitoring. It's coming from a watering hole in the Namib Desert. We've got some demonstrations connected to this wonderful doggy daycare in Utah, where we're not actually monitoring the dogs. We've developed some vision algorithms around what the people are doing at any given time. So this person's holding a mop. He's in the process of cleaning. And we have a demonstration connected to this live stream where we're using this display of this menu to try to detect whether passersby are interested in the menu or looking away from it. So you'll see a lot of those in our LandingLens demo account. So again, this is to reinforce if you already have a camera installed, there are a lot of things that you can do with that camera. So here's the architecture that we're going to work through. This is a lot to take in at once, so I'm going to break this down a little bit. So take a look at this diagram. So we just saw a couple different camera video feeds, right? So we have a video feed over here. We have some user over here that wants to extract intelligence from that video feed. So how many cars are going through the intersection? What are the employees doing? How many of the shoppers are interested in that menu? And we're going to build that entire system here using Snowflake and LandingLens and then connect all of the pieces. So this outer rectangle is Snowflake. This inner rectangle in gray is LandingLens. We do run as a native application fully inside of Snowflake. Today, the front-end experience we're going to work with is created with Snowflake Streamlit, but there are many other options you could use here: Tableau, Power BI, any sort of custom-coded front-end application. Just so happens that we're continuing to use what Snowflake provides. So the first step is going to be to actually develop the vision model. So when you saw in the Four Corners demonstration, we're looking for passenger cars, some pedestrians, some commercial trucks. So the first step is going to be actually creating that model. And for that, we're going to need some training images. And to do that, we're going to need a little bit of code to actually connect to that YouTube feed and kind of capture the image every several seconds. So let's go ahead and do this part first, and then we'll start to put the rest of it together. All right. So Here's my homepage inside of LandingLens. If you look at the URL, you can see that it is a Snowflake URL. So we are in our Snowflake native app, fully inside of Snowflake. And there's quite a variety of projects in here, and you'll see some of the ones that I drew your attention to earlier. So here's the retail shoppers, person looking at that display. Is the doggy daycare, detecting what the workers are doing. And here's that Namib Desert demonstration. So if any of those interest you, we can absolutely set up a custom time to show them to you. But we're going to start with creating a new project as if we're doing this from scratch. And we're going to use this option to sync Snowflake data. So because we are doing this live, there's a few steps that I had to do in advance to make sure that things were going to be ready. So I have done the image capture and saving them in a Snowflake stage in advance. So we're going to access this schema named Four Corners. And in there, there is a Snowflake stage called Training Small that has about 100 images in it. So this is wonderful because it minimizes data movement, right? Once I already have my images inside of Snowflake, I can use the sync functionality to bring them inside of LandingLens. So while these images start to load, I will also draw your attention to some other resources available. Last week, we published a Medium article on the Snowflake Builder blog. This is going to go through a lot of the same information that we're going to go through today, including this architecture. And there is also an edited video. This runs about 40 minutes, and it shows a little bit more of the process because I can put the video on fast forward as I'm working, and we can't necessarily do all of those steps live. So coming back to our project here, the import process is running, and we have 98 images imported, and you can see they're all kind of showing as unlabeled. So first step in developing a custom computer vision model is labeling some images. And our user interface really makes this quite easy to do. I'm going to go ahead and create a class called passenger vehicle. And we'll give it the color aqua, save that class. And now I've gotten pretty proficient at this with my mouse and also my keyboard. I'm going to start drawing what are called bounding boxes around any of the passenger cars and trucks in the image. And this is really where you need to be clear about what is the business problem you're trying to solve. So are we really trying to detect all the vehicles in the image, or are we trying to detect the vehicles that are kind of in the roadway that are moving? Notice I've selected not to draw boxes around these stationary vehicles, and I'm also not drawing boxes past this kind of back intersection. And these are just rules that I've created for myself, which are going to be important as you have multiple people involved in labeling. To say, we only want you to label the cars in the roadway, ignore anything that looks like a parked or a stationary vehicle, and ignore anything that's off here in the distance. It's going to be very hard to count. You also want to create consistency in labeling where you instruct your labelers not to draw one large box around these two vehicles that are right next to each other. You really want to ask yourself, how would a human view this image? And clearly a human would say, well, there's two white cars there, not one white car. So you would want two boxes. So I'm not going to bore you with actually hand labeling all of these. The nice thing to know is that LandingLens really only requires a minimum of 10 images labeled to get started. And so it took me maybe 5-10 minutes this morning to label 10 starter images. So we're going to do a little bit of the cooking show fast forward, and we're going to go to this project. This is the same images that were imported this morning. You can look at the timestamps here, trained 29 minutes ago. So this was all kind of set up in preparation for today's session. So let's take a look at what we have. So exploratory data analysis, super important. I love this data summary. It gives me a really quick sense of what's going on with my data. So I have 98 total images. At this point, 20 are labeled. Within those 20, we've labeled 146 passenger cars and trucks, couple ambulances, couple commercial vehicles. So data summary, super, super helpful. And you can see that I've trained a couple models. So I mentioned to you that the absolute bare minimum is 10 labeled images. So I did start with this first model. And you'll see indeed, there were 8 images in the train set and 2 images in the dev set for a total of 10. So absolute bare bones to train an initial computer vision model. And you might ask, like, well, why would you want to do that? It's clearly not going to be very accurate with 10 images. So why would we do this at all? And the main reason to do that is to then accelerate the labeling process. So let me go ahead and filter on any of the images that are unlabeled. And even though they're unlabeled, you should be seeing some dotted lines on top of the images. And these are actually coming from the model predictions that have already been done. So I'm going to go ahead and toggle that off. A little bit of terminology here. Ground truth in machine learning kind of refers to like what the human expert has labeled this image as. So none of these images have any ground truth, but they do have predictions from those early models. So let's go ahead and click into this first one. And over here on the right-hand side, I'm seeing labels, no labels yet, but I'm seeing predictions from those models that I ran this morning. And this is really the reason for training a model with as few as 10 images, is it's going to start to make the labeling process go much faster. So I'm going to turn on the label assistant. I can adjust the confidence threshold here. And there are 7 suggestions. So the early model, which again is not very good because it was trained on very few images, is finding 5 passenger cars and 2 commercial trucks. So I can go ahead and accept all of those suggestions. And now after I've accepted the suggestions, clearly I still need to make some adjustments. So there's some smaller vehicles back here that were missed. I can tighten up the bounding boxes, make them a little bit tighter around the vehicles. And then add these bounding boxes for these commercial vehicles that were missed. So the process of working in LandingLens is highly iterative. It's very easy to spin up the GPUs to train a new model every time you label a couple additional images. So I'm going to go ahead and accept this. Here's an example where a couple vehicles are too close together. So I'll go ahead and make some adjustments there. Make an adjustment there. I see one more car there in the distance. And at this point, I might label 5 to 10 more. And then I would say, okay, it's time to train another model. So each time I train a model, that label assist is going to get better and better. Right now, you just saw me hit the train button. So I've got a little pop-up notification that training is in progress. Indeed, we've got a new model card, and I can monitor this training. So what's actually happening here is that we're using the GPU compute coming from Snowpark Container Services. This is wonderful because your researchers, your subject matter experts don't need to deal with low-level infrastructure provisioning. Again, all the data stays in Snowflake. You make use of your Snowflake compute. You can easily do tracking and chargebacks based on which warehouses you're running on. So it makes that process very easy. Here we're going through different training epochs. Epoch is another one of those machine learning terms. It basically just represents an iteration between adjusting the numerical parameters in the model and then evaluating that on the dev set. Lower is better, and this kind of default training is set to stop after 15 iterations. So what are we going to get after 15 iterations? Well, we will get something very much like this one, where we can view this performance report. So In this small example, we just have 4 classes: ambulance, commercial truck, passenger truck, and then no label. And so on the left-hand side, we have the ground truth. On the bottom, we have the predictions. And what we're looking for is most of the predictions to fall along the diagonal. I can click on any one of these boxes and quickly start to inspect kind of where is the model getting things wrong. So first off, at the bottom, 111 correct, right? That's not bad for about 20 minutes of work. Here we've got our misclassifications, a commercial truck misclassified as a passenger vehicle. Again, these models were trained on very few images just to demonstrate how quick and easy it is to get started. But this kind of visual inspection of what's going well, what's going poorly, is actually really powerful for those model iterations. So you can see iteration number 3 is already complete, and we would expect the training metrics to get a little bit better each time. Okay, so let's go back to the slides and kind of recap what we've done so far. So you saw the original camera feed. You did not see me actually putting the images into a training stage, but you did see me syncing 98 images into LandingLens. Then we did some very minimal drawing of bounding boxes around the objects of interest. We defined our rules for really what is the business problem. We want to find the moving vehicles that are going through the intersection, and we trained an initial vision model. There is so much more to this, right? There are different model architectures, there are image augmentations, there are different hyperparameters. If those words didn't mean anything to you, that does not matter. But we did the absolute bare bones of vision model training, and happy to show you more advanced versions of that. But our goal for today is to build this whole pipeline. So we're going to continue building. So onward we go. All right. So we're going to fast forward to the completed project. This is the actual one that you saw the initial predictions being made are actually connected to this particular project. And you can see, again, this idea of iteration in modeling, but also keeping experiments organized. I have worked with some extremely disorganized data scientists where it's really hard to find other people's work. So I actually always just draw attention to the fact that you can have multiple people working in this account. They can be trying multiple different settings, and all of the work remains kind of organized, and you can always roll back and investigate any of these previous models. So the most recent one up here, this is kind of my personal shorthand for naming models. This was trained on 397 images, and it uses the rep points architecture with 37 million hyperparameters. Again, if that doesn't mean anything to you, that is okay. The point right now is that this model has not been deployed. So if we look at the top row here, there's an option to deploy these models, and this one has not been previously deployed. So we're going to go through and do that process. And actually, I meant to show that in the slides. So we're going to do this step. So now that we're done with our vision model, we say this is our best attempt so far. This is the one that we're ready to use. We're going to deploy that to an API endpoint. This API is also going to be inside of Snowflake. So it's great for security and scalability. It's going to offer automatic horizontal and vertical scaling. And this entire deployment step, you're going to see me do in about 2 clicks, like less than 1 minute. As Adrian mentioned, I used to lead a fairly large international team, and this particular step often took 2 to 3 weeks. And we would need to schedule it far in advance to get on the calendars of the engineers that did the deployments. So if you've never actually done a model deployment, you may not initially appreciate the time savings of what you're about to see. So we're going to hit the deploy button. We do have a couple different deployment options. Today, we're going to use the cloud deployment. Self-hosted is the other option. And I'm going to go ahead and just create a new endpoint. I'll just call it test to delete number 2. Reminds me to clean up my account later. I could spell the word delete. And we'll go ahead and deploy that. And it has been created. So honestly, if you've never done that before, that can take a strong team 2 to 4 weeks to complete. We've taken an entire convolutional neural network trained with a particular set of packages and settings and now made that available as an API endpoint in Snowflake Cloud. So here we're on test to delete. And now we've got some code where we can interact with our model. So we can interact with it in Python or with SQL. Today we're going to be working mostly with the Python option. There are other tutorials and videos for the SQL option. But the main thing actually is that, the model is ready to use. There is this nice kind of try this model option where you can just kind of drag and drop an image just to try it out. But again, to me, this is kind of a model that is in the research stage, right? Like this is not actually connected to that live camera in any way. But it is a good way to test out your API endpoint before you put it into production. All right, do a quick time check here, quick coffee break. All right, and we're going to move onward. I'm actually surprised this is taking so long. So let's move on. What next? So we now have our API endpoint. We have the Python code to be able to interact with it. So now we need to actually send some new images through it. Let me back up one slide. This was the other option, which I did not select on that deployment view. So there was the cloud option and there was the self-hosted. So with self-hosted, we would actually be downloading a containerized version of the model. And you can see at this point, it is outside of Snowflake and outside of LandingLens. So this is another option for deploying your model. For today, we're going to continue to work with the API endpoint that does remain inside of Snowflake. And so we're going to need to now connect this up to some inference images. Inference is another machine learning term. It really just means like using the model to make predictions on images it was not trained on. And the nice thing about video, right, time marches forward. There are always new things happening in the video feed. So what we need to do now is take our video feed, capture some images, save those in a Snowflake stage, send them through the API endpoint. And then, of course, we need to save the result, save the response. So we're going to grab the images, send them to the endpoint, and then we're going to save the responses in a Snowflake table. So this one is the icon for the stage. This is where we would put unstructured data like images. This is the icon for a table where we're going to have structured data. So I'm going to shift over to Snowflake and show you both this stage and this structured table, and then we will connect this all up. All right. And this is where we're ending. We're ending with the final dashboard. We're going to get there pretty soon. Okay, there's a lot going on in this view. But we've got a database called CFMLE, stands for Customer Facing Machine Learning Engineers. And here we have our four corners demonstration. So inside here, there are the stages I told you about. So here's inference images all. And I'm going to go ahead and refresh this. And we can even sort it. It looks like it's already sorted correctly. So this is the internal stage, which is holding all of the images that have been sent for inference as part of this Four Corners demonstration. And you can see some of these were sent very recently. So, to me, attending webinars, I always like to see that it's working live now, not that it's a completely canned demonstration. So this is all happening live. So these are the images that we're capturing from May 7th. And here's the structured table where we're inserting that data. So we'll go ahead and just preview this. So imagine taking each image and actually then recording the location of each object that is found. So in this particular image, looks like this first one, 06-48. And then the next image, oh, they're a little bit out of order. Okay, there's some 48s and some 50s mixed together here. But clearly in any given image, there can be more than one vehicle, right? So what we have here is for that particular image, there's an other oversized, and here are the exact coordinates of where it was found. Also the confidence from the model in that prediction. And we're getting mostly passenger cars and trucks, which makes sense from that intersection. So this is really the process of turning this video feed into a structured table in Snowflake. We now have a day, time, minute, and second stamp. We know exactly what object was found, and we know like where in the picture that object was found. For kind of traceability purposes, we also know which endpoint made that prediction. So this endpoint is going to be connected to like which of the models in LandingLens made that prediction. So as you're improving your models and changing your endpoint, you can always roll back to which model made that prediction. Okay, so now that we know what we're trying to do, let's see the code that actually does it. So this we're now going to shift a little bit into code land. So if you are not a developer, if you're not familiar with Python, just focus on the concepts. I'm not going to be going row by row through the code. I am showing that this is in one of our public repositories in the Landing AI on GitHub. So there's helper scripts and then things that are Snowflake specific. So this exact starter code is exactly what you're going to see me run here. The only thing missing, of course, are the actual credentials where you need to insert your own. So that is available to you, but let's go ahead and see it on my computer where I do have all of those different pieces filled in. All right. So this is a script called YouTube Inference Four Corners. I actually have this set up scheduled as a cron job, so it runs roughly every 15 minutes, and that's what keeps our demonstration populated. So once you create something like this, you can leave it running 24/7. You can schedule which hours of the day you want to be capturing images from that video feed. And honestly, most of the code here has nothing to do with Landing AI or the Snowflake. It's really just the guts to make it all work. I'll draw your attention to line 12 here. So from landingai.predict, import Snowflake native app predictor. So we do have our own Landing AI SDK, and it offers this very easy function to make predictions from Snowflake. So here we're doing a lot of connections. So Snowflake configuration, all the security, connection parameters, where do I actually want to connect? And then here's that endpoint ID. So when I deploy a new model, actually, why don't we even change it out? So congratulations. I'm going to take this endpoint ID. And that's the one we just deployed together, right? That's my test to delete too. And we'll go ahead and actually update it here. And I'll go ahead and save that. So I was drawing so much attention to rapid iteration previously. So we trained a model with 10 images and then with 20 and then with 30. So here's my, newest endpoint ID. As I improve my model, all I need to do in this script is update this endpoint ID. Nothing else needs to change. This is the very easy function that we provide. So Snowflake Native App Predictor. I just need my endpoint ID, the URL for my application, which comes up here from the menu bar, and then my Snowflake credentials. There's a lot of things here related to which YouTube feed do we want to connect to. So this is the four corners. We want to capture each image at 460 pixels wide. The higher the resolution, the easier it is to detect objects, but also the longer it takes for your model to run. So there's always a balance between how many pixels do you actually need to find the object that you're interested in. This captures a new image every 10 seconds. It does it 10 times and then it automatically exits. And it's going to save those images to this local folder. So let's go ahead and actually do that part. So I'm going to run this script. And you should see new images being added to this folder. Excellent, we got the first one. And again, it should wait 10 seconds, do that 10 times. You can see I tested it about an hour ago. And so this is the process now of capturing new images and saving them into this stage. So this is kind of this process right here happening. All right, let's look at some of the rest of the code. Again, just focus on the concepts. This entire section just deals with connecting to YouTube. This is going to be specific to the type of camera that you're using and where your images are coming from. If you want to do something like this yourself with some other YouTube feed, this should work for you just fine. And then here's our main loop. So every time we capture a new image, we are going to do this statement right here on 138. So again, it looks like there's a lot of code here. A lot of it is what's called exception handling or error handling if things go wrong. Luckily, tested it this morning, nothing's going wrong. And so line 138 is really the only key line here. So the predictions are being returned by calling predictor on the most recent image. Here we've got the statement to upload that into Snowflake. So we're using the put commands to put that into a stage. And then here we're extracting all of the structured information. So you saw the table with the columns that had the file name and then the endpoint ID and the, year, month, day stuff broken down. So this is the insert into this table that we were seeing. Okay. So I think we do a lot of emphasis on how our model development is no code, low code. But the reality is, like, once you're going to put this into a production system, you are going to have to interact with the API programmatically. So hopefully that was like just enough of a taste to make it real and show how it works without turning off the group that is non-technical here. So these are all very standard functions, something that like any intro developer in your organization could follow along with, especially with all of the tutorials that we provide. Okay, so let's see, how far along are we here? So we've captured several new images, great. And now if we go to our objects detected table, we should actually be able to refresh this and see the most recent ones, although I think the sort order is off. So let's do this. Let's go on to the next step. So we've got the inference results. The next thing we want to do in Snowflake is turn that into an analytical view. So we've saved all of the results to a structured table, and now the view is going to be connected to the table. And what's nice about Snowflake views is that they will always stay current with the data in the underlying table. So let's create this view now, and that's actually where you'll be able to see the most recent inferences hitting. Okay, so here's this view called objects detected view. And this is really largely the same as the objects detected table, except I've added a few other things. So for example, we added the day of the week, which might be a nice feature once we start to create some dashboards out of this. But fundamentally, this is the same information as the table with a couple additional rows added. And then we've created another view. You can see the SQL that originally created this view. This is an aggregation on that objects detected table where we want to aggregate based on the timestamp. So don't worry so much about the code. It makes more sense once you actually see the data. So what have we got here? So we've got another structured table, right? We want to turn unstructured images into structured data, and then we want to be able to connect dashboards to this. So for May 7th, in the 10 o'clock hour, you see the little 10 right there, we have processed 40 images. In those 40 images, there has been one bicycle. In those 40 images, there have been 2 fire trucks. And then if we scroll down to row 9, this is the beginning of the 9 o'clock hour. So on May 7th, 9 o'clock hour, we processed 49 images during that hour. And in those images, we had 2 motorcycles. So this is all done by aggregating on that original table where we just have the raw objects detected. And now we can aggregate by the timestamp and by the type of vehicle. And this one I know actually is sorted. So when I refresh this, we should actually see these image counts go up a little bit. I may have to run the script again for us to see them go up a little bit. But since it's now the 10 o'clock hour, hopefully you believe me that this is all working live real time. Okay, we're getting close. We're getting very close here. All right, so we now have our analytical view. And if you've worked with Streamlit before, it is nice to connect your front-end application to a view rather than to the table, because the view will always be updated based on the underlying table. So I'm going to show you a little bit about the front-end application, how it draws from this view. I also want to mention that this is a time where you can bring together other data. So maybe you have weather conditions from this municipality. Maybe you have, other like outages about traffic lights. Maybe you have, the farmer's market schedule, right? There's a whole variety of other things that would affect the number of vehicles that might be interesting other data to pull in that you have in other structured Snowflake tables. Another thing which we're not going to see in today's demonstration, but because you have all of the images in a stage, you can also display those images in the application. So you can create a nice front-end experience where you have the original image with the predictions overlaid. So this is an optional step. Since you already have the images in Snowflake, you can bring them into the application. So let's go ahead and take a look at it. So this is a Streamlit application. I'll show you my list of Streamlit apps here. And we'll go ahead and wake this one up. So we are, as Landing AI, we are not focused on like dashboarding and reporting. There are many wonderful tools to do that. This is really just an illustration of how to connect all of these pieces end to end. So I'm not going to claim that this is the most beautiful or the most insightful dashboard, but it does work. So we've got a tab here with today's counts. We've processed 109 images, detected, 1,256 objects. And then there's a section to show some historical trending. So all of this is functionality provided by Snowflake and Streamlit. So I can look at this data monthly. It's going to It's going to look a lot better if I sort it to more recent months. So how about we'll just go April to April. I could have included today. And then usually it's much more interesting if you turn off the passenger cars because you get a much better sense of the things that are not passenger cars that go through this intersection. So again, this is not the focus of the demonstration. You can build whatever dashboard you want to display the metrics the way you need. But I am going to show you the code behind this. So because I created this application, I have edit access to it. So this is the code that actually powers this application. And if you've never worked with Streamlit before, what I like about it is you can make a change to the code and then immediately see its update in the UI. So I just added this word new. So it really offers a very nice kind of iterative development experience. But the main thing to focus on is this. So here we are selecting all of the information in the view called label counts by date time. That's the one that I showed you previously with the aggregations by hour. And we're selecting all of the information in the objects detected view where the date is today. So this entire front-end experience is driven by these two views. So again, coming back to show them to you, we've got objects detected. So this is that kind of line by line list of all of the objects. And when we bring it into the application, we just filter it on today's date because we don't need to bring in all of these rows. We just filter on today's date. And then here we actually do read in all of the data, and then we give the user the option to use the date select to restrict which ranges they want to see. But this is all fundamentally connected back to this intersection. I need to advance this to real time. And that, I think that actually completes most of what we wanted to do here. So let me just kind of recap what we did, and then we've got a solid amount of time for questions. So we basically demonstrated how you can use two tools, Snowflake and LandingLens, and a little bit of Python code to connect up a front-end application to a live camera feed. We used a live camera feed on YouTube, but this could be any camera feed, any proprietary CCTV camera. The only thing that would be different would be the initial image capture. So we captured enough initial images to train a model. That intersection, you would want daytime and nighttime images. It's in Michigan, so it snows there. You would want, sunny images and snowy images. So the more diversity you have in your images, the better your vision model is going to get. But that's why I really emphasized how easy it is to iterate and then just quickly switch that API endpoint. So you can build this entire pipeline, get it working, and then continue to iterate on the quality of the vision model. And all you need to change in the code is going to be that API endpoint. I was doing a little bit of research about how organizations typically build a pipeline like this, and there are often 3, 5, 8 different technologies involved. So what I really like about this is it is just Snowflake and LandingLens. You can repeat it for, the 4 camera feeds that we looked at. It's the same workflow, same process. So once you iron it out, you're going to be able to repeat this concept on other video feeds very, very quickly. So let me pause there and we'll see what questions have come in.
Great presentation, Andrea. Our first question, can you go over what the expected inference latency is for this setup? For example, what's the max FPS it can handle?
Ah, max frames per second at the edge it's over 10. I think it's approaching 30, which is quite a lot. So, If you need more than 30 frames per second, let us know. At some point, you need to make the model smaller so that it runs faster. So it becomes an accuracy speed trade-off. But for most people, they're very happy with 1 frame per second on live video. We rarely actually run into use cases that require more than 1 frame per second, but like 30 is definitely achievable.
Excellent. Next question. To be clear, was this pipeline based on batched images saved every few minutes from the stream, or was it real time? Follow up. I'm interested in getting real time or pseudo real time, which can show an exhaustive list of objects direct detected on a video stream.
Ah, um, so this is, I would say it's real time, not batch, because it's running through it's making the prediction each time this loop runs. So to spend a little bit more time here, we're going to capture one image, right? So there's a function to capture and save the image. And then it's going to send that particular image for inference. So, although I emphasized the 10 images every 10 seconds, I did not gather them and then score them all. I am actually gathering one and scoring it. So, for example, I could, so on my sleep seconds here, right, I could put this down to half a second, and I could put, iterations on infinite and then just let it run. Yeah, if there's a follow-up on that, feel free to, I think my email is on this like final slide. So
Here's,
yeah, or
here's,
yeah, I'll add it on here.
here's a follow up to that question. You may have
Mhm.
already answered it in your answer, but let me just read it.
Yeah.
If one wanted pseudo real time inferencing, could we just set up endpoint to iterate on the endpoint or input image stream every hundredth of a second or so? Does that make sense?
Um, can you read that one more time?
Certainly. If one wanted, and it's from the same person,
Yeah.
if one wanted pseudo real time inferencing, could we just set up the endpoint to iterate on the input image stream every hundredth of a second or so?
Yeah, I don't immediately see any reason why you couldn't. Yeah, let's feel free to contact me on the details. Like we rarely see use cases that require less than 1 frame per second. So just so I don't give you the wrong answer, but I don't see any reason why you couldn't do that.
Oh, he said you just answered it. Okay, great. So, next question, and this will unfortunately be our last question. How can you make a mass integration of hundreds of cameras?
Um, so there's a couple things going on there. One is like, is it the same model on all of the cameras? So like, let's go back to like the doggy daycare, for example. That particular business actually has multiple rooms, and so they have like cameras in each room. So they don't have hundreds, they have about 8. But they could actually be running the same computer vision model on the feeds coming from those 8 cameras because it's the same use case. So at that point, this is really just about horizontal scaling, and you can achieve that with partially with Snowflake, but then if you hit a maximum, you could just have multiple deployments of that model. So for example, like you saw me deploy the model to an endpoint, maybe that endpoint is sufficient to serve 5 cameras. And so to serve 100 cameras, maybe you need 20 endpoints. So there's a certain element of also getting your Snowflake sales engineer involved in terms of like the horizontal scaling and when you would need multiple endpoints. So that would be 100 cameras, but they're all doing the same thing. This also happens like in retail stores, right? If you're trying to monitor like the length of the queue, but you have like roughly like the same setup, right? You have the same model for all your stores. If we're getting into 100 cameras where the use case is different for each one, right? Like now you're going to have 100 projects in LandingLens, 100 endpoints. So you get the repeatability of the process. But then it's really just about like the throughput on one camera because they're all different use cases. Hopefully that helps.
Excellent. And with that, this brings our webinar to a conclusion. Andrea, thank you for a fantastic presentation, demo, and live Q&A. For everyone on the call, we really appreciate your time today. We will send a recording tomorrow, and we will also have a link to schedule a time with one of our computer vision specialists to talk about your use case, and we would love to talk about your use case and see what we can do to help you. I encourage everyone, if you haven't already, please sign up for LandingLens, join our community, get certified, follow us on LinkedIn, Twitter, and also sign up for our newsletter and look for our future date for webinars. Have a great one, everybody. Thank you again for joining us.